Hello there, boys and girls. We are going to move on and talk about the antiderivative involving natural logs. Before we do that, I've started on a blank page just to show you something, and that is if you have the integral, indefinite integral of 1 over x dx. It's very tempting to try to pull this and make this x to the negative 1 dx. And then to try to use a power rule. And if you use the power rule, you would raise the power by 1 and divide by 0. But that's a big no-no because you can't divide by 0. So if you go back to what we originally say when we look at an indefinite integral, what function, when you take the derivative, will give you 1 over x? And that involves our natural log. So let's go on and take a look at the notes now. All right, before when we were looking at natural logs, we had a derivative rule that said you would take the derivative of the argument and put it over the original argument. So for an antiderivative, you need to be able to recognize it in all of its different forms. You've got 1 over u du. You could have du over u, or you could have u to the negative 1 du. Because all of these are the same thing, they all go back to when you take the antiderivative, you'll get a natural log. So you just need to be able to see the different forms of all of them in order to do the antiderivative properly. So this is going to be the natural log of the absolute value of u. And that's something that's a little bit different than when we would take derivatives. And that's because when we would start off with a natural log, we would assume that the argument is positive. Well, here, if you start off with an antiderivative, you have to force the argument to be positive because you can't take the natural log of a number that is 0 or less. Okay, so by forcing it to be positive, we're going to put the absolute values around it. Now, just like before, the u is representing a function of x here, so this is going to involve U substitution if it's ever anything other than just 1 over x dx. That antiderivative is just the natural log of x plus c. But if you ever see a quotient where the variable is in the denominator, most likely it's going to be a natural log antiderivative. So let's go ahead and take a look at some examples. The first example is pretty straightforward. We've got an x in the denominator. So I'm going to do a U substitution, and I'm going to choose my u to be 3x plus 2. If you do that, this indefinite integral is going to turn into 5 over u, and then I've got a dx hanging out over here. If you want to simplify this and pull the 5 out to the front, this is going to be dx, and I'm going to actually split it up and say it's 1 over u dx. Okay, so the 5 came out to the front, that leaves a 1 left over in the numerator. Go over back to your u equation, take the derivative of that, and you'll end up with a 3. That means that du equals 3 dx. And I've gotten out of the underlining of things, but dx was all I was trying to get rid of over here. So there it is. And we're going to divide both sides by 3, so 1/3 du equals dx. Okay, so that's a nice clean substitution. I've got the 5, 1 over u, and then I've got this 1/3 du. I can pull the 1/3 out, so this makes this a 5/3. 1 over u du. And now it's in the form that's shown up in this box up here. This is the 1 over u du. So that is an antiderivative that'll give us the natural log of the absolute value of c. Trying to put a times in there. There we go. 5/3 times the natural log of the absolute value of u plus c. And then the last step is going to be to substitute in And there it is. Sometimes the antiderivative turning into a natural log is going to be in kind of a sneaky form. It's example number 2 right here. We've got the antiderivative of the tangent of x dx, and it's very tempting to try and think of a function that does that, and there's no function that we know of that turns into the tangent of x when you take the derivative. Some people are saying, well, secant squared, but remember, secant squared of x is the derivative of tangent of x, not the antiderivative. So we're going to use a clever little rewrite of this and turn this into the sine of x over cosine of x dx. And the reason that we want to do that is because now we have a quotient and we're going to use a U substitution. For the most part, when you have a fraction with a variable in the denominator, your U is going to be the denominator. And I know you wouldn't think to do that, and I don't expect you to for the first couple of times without some assistance, but you're going to, again, start to see the technique in U substitution. So if you let U equal the cosine of x, then that indefinite integral turns into the sine of x dx all over U. And I'm going to just take another little step here and really separate the u's from the x's. And this is going to work out really nicely now, because if you go back and look at your indefinite integral, you've got the sine of x dx, which is what we're trying to get rid of, and go back over to your u equation. You've got du dx equals derivative of cosine of x is negative sine of x. So this is going to work out because we've got negative sine of x dx, and just divide both sides by that negative, and you'll have negative du equals the sine of x dx. So there's that perfect, lovely substitution that we were looking for. And now go back to your indefinite integral, and you'll have the indefinite integral of 1 over u, negative du. So pull out the negative into the front, and you'll have 1 over u du. And 1 over u, as we saw up above, turns into the natural log of the absolute value of u. And in this case, u is cosine of x. So I'm starting to skip the step where I just leave it as u. I'm going to change it over to our substitution piece right away. So we've got the negative natural log of the cosine of x plus c. Okay, so again, you can always double check your answers by taking the derivative of this, and if you do, the derivative of a natural log is the derivative of the argument over the original argument. Derivative of cosine is negative sine of x, and it would be over the original argument, which is cosine of x, and that negatives is going to the negatives are going to cancel then, and you'll end up with tangent. So it works. All right, I want you guys, there's 3 practice problems on this next page, and I'm going to have you do all 3 of them on your own and then come back and check your answers. I'm going to go ahead and tell you the U. If you would like, go ahead and hit pause now and try all 3 of them on your own. I'm guessing that some of you would like a little assistance picking the U. Be courageous, though. Try to hit pause and see if you can at least figure out the U's and then come on back. Okay, for the first one, you're going to let U be 2 minus the sine of 3x. For the second problem, you're going to let U equal the natural log of x. And for the last problem on the page, you're going to let U equal y minus 1. Okay, so I'm going to give you about 5 seconds right now to hit pause, and then when you hit unpause, you're going to see that all the answers are up. So hit pause and go ahead and try all these on your own. And here's a little math humor for you. If you have the antiderivative of 1 over mower d mower, anytime you have 1 over a variable, you're going to take the natural log. So this is a natural log. So this is a lawn mower. Get it? Good times. Yeah, you can go back and rewind and take a look at that. That's all good. All right, here come the answers. Are you ready? Are you ready? Are you ready? Okay, so double check and make sure that you picked that you took the derivative correctly and did all the substitution, and your final answer is shown. I'm hoping that you got that one okay. And let's go ahead and show the answers to number 4. So if you didn't do the work for that, hit pause now because you're getting them in 5 seconds. All right, I'm actually going to talk with you on this one because this one's a little bit different. So the first thing, if I take that substitution of the natural log of x, and I'm going to get 6 over x, u cubed, and then dx. So I'm going to separate this, pulling the constant out to the front, and rearranging this so this is 1 over u cubed, and that leaves me with dx over x, or 1 over x dx. X is in the denominator still. Okay, so this is just using the multiplication of all these fractions to kind of separate these things. And you'll notice that you've got a 1 over x dx left over. So if you go back over to your u equation, you're going to have du dx equals 1 over x, derivative of the natural log, right? Derivative of the argument over the argument. So you're going to have du equals 1 over x dx, and looky there, there's a nice substitution. I know you guys don't think it's nice, but I do. So let's go ahead and plug that in over there, and we'll have 6, 1 over u cubed, and that whole thing turns into a du. It is at this point that I caution you, this is not a natural log antiderivative. It is only when it is 1 over a variable to the first power that you'll end up with a natural log. So go back to what we were doing before and bring this out of the denominator. You'll have u to the negative 3 du. And now you can use your power rule. So this turns into raise the power by 1, so add 1. You'll get u to the negative 2. Divide by that new power. Don't forget your plus c. And then substitute this back in and clean things up. 6 over negative 2 is negative 3. And u to the negative 2 is going to put this in the bottom. And u was the natural log of x. And it's going to be squared. And you can either put parentheses around the natural log and put the squared on the outside. But I also want to show you that you might see it like this, where the squared is inside. So natural log squared of x, just like we do with trig functions. And then plus c at the end. Okay? I'm going to give you about 5 more seconds to try and finish copying all this stuff down, and then try number 5 on your own now that you've seen both techniques, and let's see how you do. All right, I'm going to talk you through this one. This is using the substitution that I gave you guys, and if you plug all this in, you're going to see that you need to get rid of 1 over y dy. And now, I gave you this as a u substitution because I would have guessed that that's mostly what you would have chosen. And you're going to see what to do if you get stuck, because you're going to get stuck here. So du dy is just 1. So that means that du is dy. But we were trying to end up with a 1 over y dy. So we still have y's left over in our integrand. That means we didn't choose the right u. It also means this might not even be a u substitution. So although you might get annoyed at me because now you're going to either have to erase or cross off and write this somewhere else, I want to show you that this is what most of you will do, is now that we know u substitution, you'll try to pick things apart and do it like this. So here's how it would end up, and this is how you know you did it wrong, because you end up with a 1 over 2 u squared 1 over y du, and you still have mixed up variables in here. So this isn't going to work. So let's go ahead, and I'm going to use my eraser here. And I know you can get mad at me. It's not very nice, I know. But remember, from the very beginning, I always said that if you could clean up the integrand before you do any antiderivatives, and if you can clean up a function before you take derivative, your life is going to be a little bit easier for you. So I'm going to go ahead and wipe my slate clean here, and then I'm going to show you one more technique in doing antiderivatives. All right, so there we go. Don't get mad. I like to show you because a lot of times teachers show you only the right way to do things, and then you get mad because then there's problems that you don't know how to do because they never showed you what would happen if you made a mistake. So there's the mistake. This is how we correct it. We're going to clean this up by doing some simple algebra. We're going to FOIL or distribute those two binomials, and you'll get y squared minus 2y plus 1 all over 2y dy. And this goes back to a technique we talked about at the very beginning of the unit, where now you can split this up because there's only one denominator but several terms in the numerator. And give me just a second while I separate all of these into a fraction and into their own separate little integrals. Okay, now if you clean this up, this is going to give you 1/2 y dy minus just dy, and then plus 1/2. I'm going to pull the 1/2. I should have pulled that out on the other one too, but 1 over y dy. Now there's your natural log antiderivative. Don't forget to take the antiderivatives though. So we've got the 1/2. The antiderivative of y is just y squared over 2. And the antiderivative of dy, remember this is 1 dy, so what function when you take the derivative gives you 1? And because our variable is y, we're dealing with just y. We've got a 1/2. And here's that antiderivative of a natural log. So this is going to be the natural log of the absolute value of y. And then don't forget your plus c. Okay? So the last thing it would do is probably pull this as a y squared over 4 minus y plus 1/2 natural log of y plus c. All right? All right, everyone. I hope you have a good one. Talk to you later. Bye.